Hi, welcome to the video for Edexcel Physics past paper solution. It is October 2017, Unit 1 and Part 2. So let's start. Question number 11. Honey is stored in jars at room temperature under certain conditions. Small crystals form in the honey and move around to form larger crystals. The following extract was taken from a honey producer website. Honey crystallization is most rapid around 10 to 15 degrees centigrade. At temperature below 10 degree, the crystallization is slowed down. Low temperature change the viscosity. Explain how the lower temperature affect the movement of a small crystal in the honey. This is again a typical question discussing about the relation between temperature and the viscosity. And you know that viscosity of a liquid is inversely proportional to the temperature, meaning if you increase the temperature, viscosity decrease. If you decrease the temperature, so viscosity increase. So you can say that temperature is increased, or I guess in this case they are saying the lower the temperature, so I would rather than increasing temperature. So let's see, if temperature is decreased, that means viscosity is going to increase. Increasing viscosity cause motion for crystal to decrease because of the drag force. Drag force is higher the viscosity, higher the drag force, so the motion of the crystal would be slowed. So that's how you can reframe your answer using these 3 points. So you can write like that or reframe in your own words. So viscosity inversely proportional to the temperature. So lower the temperature, viscosity increase, which causes drag force on the crystal to increase, so crystal moves slowly. Question number 12. A small ball bearing released at the top of a measuring cylinder containing oil as shown. A sphere falls reaching a maximum velocity of 7.1 times to the power minus 3 meters second inverse. Calculate the maximum drag force acting on the ball bearing. This is a straightforward question. You need to calculate the drag force, and according to Stokes' law, drag force F is equal to 6 pi eta r v. Eta is the viscosity or coefficient of viscosity. R is the radius, and v is the velocity. So if you see, you have all the 3 values. This is v, this is your eta, and this is your r. So if you put all these numbers in this equation, then you can have a drag force F is equal to 5.2 10 to the power minus 4 Newton. Add to the diagram below to show the flow of oil around the ball bearing as it falls through the measuring cylinder. Okay, so you need to add the so it's all about streamlines. in this case, you need to understand the ball is falling with a steady speed. So speed v is steady. Steady means the flow remains streamlined and there is no turbulence throughout the motion. Keep this thing in your mind due to steady. If you go back the previous part, like you can see here, reaching a maximum velocity. So this maximum suggests that velocity cannot increase then this is the maximum. That means this is after this, if the ball bearing is falling, so this is the maximum one. So what you do when you draw the streamline, so these two extreme lines should go straight, and these two lines, when reaches the ball, it will be slightly curved and then again remains parallel. You must use ruler. That's how. So be careful. There's a chance that the student gets confused and they draw turbulent flow after passing the ball. Remember, this is not the case. I hope you understand the situation. Question number 13. Trumpets are commonly made from brass, an alloy of copper and zinc. The main tube of a trumpet may be produced by pulling brass tubing to reduce its diameter and then bending it into the shape. Explain how the property of the brass enables it to be pulled to reduce the diameter of the tubing. In this case, it is all about pulling. Pulling, that means tensile force. Due to tensile force, the material can be pulled or can be put into tension, so it can be pulled due to tensile force, and because it is made of alloy, copper and zinc, and this alloy has a large plastic deformation, so can undergo a plastic deformation or large plastic deformation under tensile force. This is important one. This is the tensile force. So pulling is all about tensile force and the large plastic deformation. That's how you can reframe all these things. So it is a ductile material. This is the property, and can be pulled under the tensile or under tension. Or that's how. Part 2, explain the additional property of the brass that enables tubing to be bent into shape. Okay, tubing bent into shape. Bent is all about making sheet. And sheet, if you refer the making sheet of a metal, so it's all about the property of malleable. So the property is known as malleable. That means this alloy can be hammered and bent into the sheet. Question number 14. A student carried out an experiment to measure the extension of a rubber band. She determined the extension of the rubber band as the applied force was increased. She plotted a graph of the result. Okay, this is extension 10 to the power minus 2 meter, applied force in Newton. Okay, determine the work done in stretching the rubber band. This is force extension graph, and the work done from the graph is area under the graph. So under the graph, in fact, you need to find this area, but it's not easy. You need to do a lot of practice for such types of question, because graph is not a straight line, so you cannot use formula for triangle to find the area of the triangle, because it is a curve. So the best way is if you do practice for some question. So what you need to do, in fact, you need to calculate the number of rectangles, these rectangles, total rectangles, and then multiply the area of the rectangle, so you can have an area. So if you keep counting the area, like rectangle 1 and 2 and 3 and 4 5 6 7 8 9 10 11 12 13 14 and so on, so you have a complete rectangle. And what would you do with these region? So if you see this small region and this, you can count these three regions as one rectangle. It's just an estimation. Similarly, this region and this one, you can consider these two as one. So if you count all these one, I guess there will be yeah, it is, there are 38 squares. And then you need to find area of the one square, and you can easily find the area of this square. So area of this square, you can do length into breadth. So this is 2.5 Newton and this is 0.5. So area of the one square is 1 square area is 2.5 into 0.5, but don't forget into 10 to the power minus 2. This is okay, and this is the area of one square, and you have a total 38 square. You multiply the number with these 38, so you have work done equal to, you can do 2.5 times 0.5 into 10 to the power minus 2 times 38. So final answer, you will have 0.475 joule. This is the work done. B, sketch on the axis above a possible graph of unloading of the rubber band. Again, a typical question. Unloading of rubber band. When you pulling rubber band, so you have, this is a loading, and unloading graph has a similar shape but lower than the first one, and this is the unloading curve. Question number 15. The graph shows how the displacement of a racing car along a straight track varies with time. Displacement and the time, a curve. Uh, yes, this is a curved up, so that means it is speeding up. Okay, now let's see. A student used the graph to calculate the velocity of the car at 15 seconds. The student wrote velocity is equal to displacement over time. That means 300 over 15, 20 meter per second. That means what did he or she did? She took 15 and then calculated the displacement, 300 divided the whole thing. Okay, fine. That's okay. Now state why this value is incorrect and calculate the correct velocity of at 15 seconds. Yes, of course. Because she is stating that the velocity is 20. It is not a velocity. This is average velocity. Why is that? Because she used total displacement with the time taken, and this approach is for average velocity. So this is not just a velocity, this is average velocity. uh, Instantaneous velocity at 15 seconds would be different than this, and calculate the correct value at 15 seconds. So correct value at 15 seconds can be determined using after drawing the tangent at 15 seconds, and you know how to do that. Draw the tangent line and calculate the gradient of this line. It will give you the correct value. So that's how would you explain first that this is not the correct value. 20 meter per second is not the correct velocity, it is average velocity. And of course it's not a constant and is the average velocity. And for correct value you need to plot tangent line, and on this tangent line you need to choose 2 points to find the gradient. So I guess here I can choose this point and then these points. These 2 points can be used to determine. So if you see, this is the coordinate of this point is 19.5480 and this one is 10.5 and 100, and you can use these 2 points to find the gradient, and gradient is gradient from a line is y2 minus y1 divided by x2 minus x1, which is rise over run. So you can do that. Speed is the gradient, and gradient is 480 minus 100 divided by 19.5 minus 10.5. So V will be equal to 42.22 meter second inverse. This is the correct velocity. The gradient of the graph continued to increase as the car traveled along the track. After 20 seconds, the rate of increase of the gradient began to decrease. Explain why the rate of increase of the gradient decreased. If you see, initially, the meaning of this question is, initially, velocity is increasing, so gradient is increasing with a faster rate, but as the speed is increasing, gradient is not changing much. That means the rate of increase in the gradient is decrease. So it's all about, because at high speed drag force increases, and due to increase in the drag force, acceleration of the car or of the object decreases. That's why the rate of increasing the velocity is decreasing. So you can reframe the answer like that. Since the velocity of the car is increasing, which causes drag force to increase, and due to which acceleration of the car is decreasing, that's why the rate of increase of the gradient decreases. Thank you very much. That's it for this part. We will see you soon in the last part, in which I will try to finish this paper. Thank you very much.